relativity that mass and energy are but different manifestations of the same thing, a somewhat unfamiliar conception for the average mind.
Was Albert Einstein right when he predicted that we would never be able to see to the edge of the universe? The Webb telescope has now observed a void in the extremely early universe that could now confirm this prediction. But what are we really seeing here? Is it really a void? And could it be the beginning of the universe? 100 years ago, scientists slowly began to look beyond the edges of the Milky Way, and what they saw astonished them. At first, it was just hazy nebulae. Then it became clear that these nebulae were other galaxies. First, the Small and Large Magellanic Clouds were observed, followed by the Andromeda Galaxy. It was then that scientists realized there were far more galaxies than they had ever imagined. These discoveries sparked groundbreaking ideas, such as the evolution of galaxies and the concept of an infinite universe. Shortly afterward, Edwin Hubble observed that distant galaxies were receding from us, leading to the theory of cosmic expansion. Not long after, Belgian physicist Georges Lemaitre proposed the Big Bang theory. All of this occurred shortly after Albert Einstein introduced his theories of relativity. Many of the theoretical predictions made by researchers in the 1910s and 1920s were later confirmed by these new discoveries. However, throughout his life, Einstein remained uncertain about whether the universe truly had a definitive beginning or end, even though he ultimately accepted the Big Bang theory. Despite this, Einstein was firm on one intriguing point. Even if the universe did have a beginning and an end, he was convinced that we would never be able to observe them, no matter how advanced our telescopes became. But how did Einstein arrive at such a radical idea? And what connection does it have to the cosmic void recently discovered by the James Webb telescope? Einstein was undoubtedly one of the most influential physicists of the 20th century, and many of his predictions remain foundational to modern science. One profound insight was his assertion that we could never directly observe the universe's absolute beginning. Einstein provided two compelling reasons for this. First, the Big Bang theory and related models suggest that no light existed for hundreds of thousands of years after the Big Bang, a period scientists now refer to as the Dark Ages. If there was no light, how could we possibly observe this era with telescopes? Today, scientists have explored intriguing alternatives, such as using radio telescopes. These instruments don't see, but rather hear radio waves. However, researchers believe that the Big Bang wasn't a loud explosion, but occurred in complete silence. The space in which sound could travel didn't even exist at the time. The Big Bang itself brought space into existence. Radio telescopes, instead of detecting sound, capture waves that are far outside the range of audible sound. Space hardly conducts sound, and only certain types of waves pass through the interstellar medium, which can be made audible with modern technology. We would therefore not be able to hear the presumably silent beginning of the universe. In the 1960s, we discovered cosmic background radiation and have since mapped it extensively. This radiation is considered a remnant of the Big Bang, and much of the evidence for the Big Bang theory comes from it. However, the microwave background has never led us directly to the Big Bang itself, so we still have no way of detecting or proving the absolute origin of the universe. We would therefore not be able to hear the presumably silent beginning of the universe. Einstein believed for another reason that we could never see the true beginning or edge of the universe. He proposed that, due to the constant expansion of the universe, the beginning would move further and further away from us, effectively placing it out of our observational reach. Additionally, Einstein theorized that space might be curved, meaning the starting point could lie behind a kind of cosmic horizon, forever hidden from our view. Keep in mind, this was during a time when the best telescopes could barely make out neighboring galaxies. Today, We know there are millions of galaxies in a universe that is constantly expanding. Despite the vastness of space between galaxies and galaxy clusters, modern telescopes can now see 13.6 billion years into the past, very close to the Big Bang itself. With the James Webb Space Telescope, we are inching ever closer to observing the earliest moments of the universe. You may have heard that the James Webb Space Telescope has uncovered an astonishing number of very ancient galaxies, which has even prompted some to question the Big Bang Theory. However, did you know that the JWST has also discovered a peculiar void that might support Einstein's prediction about the unobservable nature of the universe's absolute beginning? Absolute voids are enigmatic regions of the universe, so devoid of matter that they seem to challenge the theory of relativity. But how could this discovery possibly affirm Einstein's idea about the invisibility of the universe's origin? Initially, the void was thought to be a remnant from the Dark Ages, a period right after the Big Bang when there were no stars or galaxies. Some researchers believe this finding confirmed the existence of this early epoch. However, the James Webb Space Telescope seems to support Einstein's perspective in another intriguing way. So far, it has found no evidence of the universe's beginning or an early stage. The images of what were thought to be extremely ancient parts of the universe reveal structures and galaxies that appear similar to those in the more observable universe. This raises the question of whether a mysterious void could have been the origin of the universe. While we cannot completely dismiss this possibility, it's important to acknowledge that we still don't fully understand what these voids really are. Moreover, we must admit that our understanding of how the universe began remains incomplete. Voids are likely empty, but we can't be entirely certain. It's possible they harbor unknown forms of matter, such as dark galaxies. Some theories even suggest that voids could be parallel worlds or remnants from collisions between universes in a multiverse. There are even outlandish ideas that aliens might be using these darkened galaxies in voids to harvest energy. These mysterious voids challenge our understanding and inspire some truly wild theories. One possibility is that our universe could have originated from a large void. The inability to disprove this notion only reinforces such ideas. This raises another question. How was matter created? We've previously discussed the concept of nothingness from which the universe supposedly emerged. If that was the absolute starting point, how could we ever observe it? After all, it was nothing and thus undetectable. A singularity is a point where forces are so condensed that our dimensions, values, and sizes fail, or where everything is concentrated into one infinitesimally small point. This point is thought to have existed in a state of complete equilibrium until an unknown event disturbed it, leading to the creation of everything we know today. Essentially, all life, every star, and every exoplanet were once contained in that tiny dot of nothing. Understanding how such a minuscule dot could encompass everything remains one of science's great mysteries. We encounter singularities in another part of the universe as well, at the centers of black holes. These black holes are found at the core of nearly every known galaxy and are thought to be the remnants of stars that have exploded. However, no one has ever explored the center of a black hole, and our ability to observe the universe's absolute starting point remains limited. Everything we know is based on calculations that seemed accurate until the James Webb Space Telescope revealed data inconsistent with our theories. The JWST suggests the universe might be older than we thought, or that its nature differs significantly from our predictions. Black holes themselves are one of cosmology's biggest mysteries. They are incredibly massive, and the forces within them are so extreme that we cannot explore these infinite points using conventional methods. Currently, Hopes are pinned on new supercomputers that use advanced artificial intelligence to unravel the universe's secrets and reveal its true nature. Scientists are also exploring the potential of quantum computing and novel chip technologies, such as those leveraging the storage capacity of water to achieve unprecedented computing power and gain deeper insights into the cosmos. If you enjoyed the video, don't forget to like the video and subscribe to the channel for more deep dives into space and beyond.